Okay, so in order to start properly our discussion, we have to first estimate our hypothetical MLs. So what are hypothetical MLs? Now, based on the discussion with Dr. Eli, we will be able to set few candidates of MLs, right? I have to have candidates for possible MLs, and I will try to do my procedure on all these different candidates and compare to agree on one of these MLs. So hopefully after this module, we will be able to understand the approach used to set or to estimate those hypothetical MLs, perform calculations in order to determine the rejection rates, and then we will discuss the calculations related to the intake or the exposure. So what are the candidate hypothetical MLs? A candidate value for an ML is identified from a high percentile values, usually around or slightly higher than the 95th percentile of the targeted data set. So I have my data set ready, I performed my statistical analysis, and now I need to propose MLs in order to work on. The first proposal that is logical to do is to take the 95th percentile as a candidate for my ML, or value a bit higher than the 95th percentile as a candidate ML on which we will be working, and now you will tell me why. The precision of the current analytical method and significant figures of the analytical results should be taken into consideration when I propose an ML. Do I propose my ML as a value of 10, 15, 5, or as a value of 15.1, 5.2, or as a value of 0.62, 0.65, 0.74, or 0.5, 0.6, 0.7? What do you think and why? I'm still thinking here about the candidate ML, the hypothetical MLs, okay? I have a data set, and I have my 95th percentile, and I want to start proposing MLs. Before agreeing on the hypothetical MLs, the significant digits or figures I will be taking into consideration. What do you think about that? When I'm proposing hypothetical MLs, I will be proposing a round value like 5, 10, 15, 6, 7, 8, or I will be taking 5.5, 6.5. So the significant digits, do you have an idea? It could be based on what? It could be based on the contaminant itself, the analytical method used in order to evaluate it, right? But we have the tendency of rounding the values, as Dr. Eli said, in order to be always in the upper value and the worst case scenario. And rounding the value is easier to verify for compliance. Do we agree on that? You can disagree and tell me why. Okay, so we're discussing here the reflection on setting those hypothetical MLs. So the precision of the current analytical method and the accuracy of the analytical method should be taken into consideration, or what we call the significant figure in the analytical result should be taken into consideration when proposing candidate MLs. So numerical values also for MLs should preferably be regular figures in a geometrical scale. So for example, 0.01, 0.02, 0.05, or 1, 2, 5, 5, 10, 15. That's normally the candidate hypothetical MLs. When we start this process, I want to have several hypothetical MLs, preferably more than 2 hypothetical MLs to work with or to work on. And normally we have more than 2. So we could have 3 candidates. With the breakout rooms, you will see situations where we will be testing for 4 hypothetical MLs candidates. So we need to have several options in order for us at the end to agree on one. Once this numerical candidate value of an ML has been determined, which we said could be the 95th percentile, could someone tell me why the 95th percentile is the candidate to start with for a hypothetical ML? Any idea? I have my distribution, and now I want to set my ML. Why the 95th percentile value is the first obvious and logical candidate for an ML? Any idea? Let's use the microphone, please, because that's the most important discussion we will be having here. I'm not saying that then I will be adopting this ML, but that's the first obvious candidate. Okay?
Because of the confidence level we chose, it was 95%.
Okay, that's not exactly the case, but it's a good start of the reflection. But let's take into consideration the idea, the definition of the percentile, as Dr. Eli explained to us. Let's remind ourselves, what is the definition of the 95th percentile? What does it mean?
It's the results that are below.
The value.
The value
below which we have.
Yes, to express it, it's 95% of the result. If you take the higher result, it's the 95% under the highest result.
Okay, so it's the value under which I have 95% of the results of my data set. Okay, and above which I have 5% of the results of my data set. Okay, remember this information now in the following slides when we'll be discussing the rejection rate. Okay, let's keep that in mind, and then you will answer us why it's the obvious first choice for setting an ML. Okay, so below which I have 95% of the data points, and above it, I have 5% of the data points. So, but for now, let's agree on the fact that the 95th percentile or a value around it is the first obvious candidate and logical candidate to set an ML. Then I need more choices to work with. So the next higher and lower value can also be suggested as hypothetical MLs. I could consider the 98th percentile, the 97th percentile as other candidates for MLs to be tested. For example, for a candidate ML of 0.5 milligram per kilogram, additional hypothetical MLs could be 0.4, 0.6, for example. Or if I have one, I could go for 2, 3, and 4 and test for those MLs. In the case of revising, I have an ML, and now I'm trying to revise the ML. I should consider the already adopted ML as a candidate again. So always I should consider this existing ML as one of the hypothetical MLs. Further values, as we said, could be obtained from the high percentile values, normally 95th, 97th, or 98th percentile value. Now, let's review that. The first step, I have my data set. I prepared it. I have to agree on hypothetical MLs, 2 values, 3 values, 4 values, on which now I will start my calculations. Any questions till now? We didn't answer yet why the 95th percentile is the most obvious one. Then I set my hypothetical MLs. The first obvious step to do is to start calculating what we call the rejection rates in percent. What are the rejection rates? And they are indicative of what? Very simple formula. The rejection rate in percent is the number of data points which are above the hypothetical ML I'm working on now, divided by the total number of data points times 100. شو بيعني هيدا exactly? Who can explain to us? From a practical perspective. Yes, Lama. From a practical perspective, what is a rejection rate? Amazing, excellent. And now this number corresponds to what? To a food commodity, right? My data point, my data result is representative of a food commodity. So when I set the hypothetical ML, all data points above the ML are indicative of potential commodities that will be rejected from my trade stream. Do we agree? So calculating the percentage of a rejection rate is the estimation or the evaluation of the economical impact of adopting this ML. Are we agreeing on that? So that's, remember always, the trade part and the safety part. So now I'm speaking about the trade part. We cannot disturb the trade stream. we have to take into consideration food security issues and the trade issues and economical issues. I cannot adopt an ML after which I will be blocking, rejecting, considering non-compliant 25% or 30% of the commodities traded. مقبول هذا الشيء؟ Okay, I will limit my discussion now on that. Then with Dr. Karima, we can discuss the part related to the exposure and intake, okay? Now, what do you think could be an acceptable rejection rate? Our all-time discussion. What do you think? 0%? Oh, let's start discussing 0%. What do you think? If I'm saying that my excellent situation, if my rejection rate is 0, am I applying an ML? I'm not applying an ML. So that's the exact situation where no ML is applied. Okay? Then I'm starting to applying MLs, and values of these MLs of my hypothetical MLs are decreasing. Okay, so I'm applying an ML of 2, then an ML, potential ML of 1. What do you think the rejection rate will increase or decrease, and why? And take the microphone. So I'm still studying several hypothetical MLs. I'm applying those MLs, and I'm calculating the rejection rate. Again, شو هو rejection rate? The number of data points or commodities that will be rejected out of the stream. Now, if I have an ML of 5, then an ML of 4, 3, 2, 1, what will happen to my rejection rate if I decrease my ML?
If I decrease my...
Think it out for a second. Think it out for a second. I'm adopting lower MLs. I will be rejecting more data points or less? More data points. So I will be rejecting more, which is normal, right? I'm being more strict. I'm applying more strict MLs, so I'll be rejecting more. Now, let's go back to our discussion. What might be for you an acceptable rejection rate? So Professor Sam started by saying 0, and we had our discussion. No. Now, what do you think? 10, 20, 30? Amazing. That's an amazing idea. So I have to take into consideration, can I reject 10? Can I reject 20? Or what? Okay. Yes, Professor Sam, any other idea? Health and food security and food security issues. Okay. So now you see this interesting discussion. It's always about that in Codex. The CCCF, to give you the answer, the CCCF, as a management decision, they decided to accept maximum 5%. They will not admit more rejections above 5%. Okay, now who can answer my first question? Why the 95th percentile is the most obvious choice of my ML? Because what is the definition of 95th percentile? It's the value above which I have 5%. So I'm rejecting 5%. Right? Okay? It doesn't mean that when they will be adopting their ML, it will be this value. But that's the most logical, obvious starting point. That's it. Yes. Yes. Excellent. Let's repeat it, okay? So it's a decision they took within CCCF. Perhaps in other situations, you will take another. You will have another recommendation within the proceedings of CCCF, the Committee on Contaminants in Food. ضمن هذه اللجنة قرروا إنه يلي بنسبهم ما بيقدروا يقبلوا rejection أكثر من 5%. Otherwise, they consider إنه it will disturb the fair trade. That's it. It was a policy decision. Okay? اعتبروا إنه if I'm rejecting 10%, it's too much. It will disturb the stream of trade of commodities. That's it. Okay? We're still discussing the rejection rate here. بعد ما عم نعمل اللينك بين rejection rate وال protective. Good? Okay, so that's a decision. Yes.
I understand. No, if it's maximum of 5%, so it would be 5 or lower.
Or lower, yeah.
Never higher.
Yes, they will not admit higher.
Okay.
يعني any hypothetical ML, when we calculate our rejection rates, giving rejection rates of 7%, 10%, 8% will not be considered. Okay? Then, in some situations, let's say I will be brought to accept, for example, 5.5%, but that will be a risk management decision taken. Absolutely. So that's exactly our exercise, what we'll be doing, okay? But the concept, the spirit of it, we agree on that? Amazing. That's the idea of the rejection rates, okay? So some assumptions, samples, we're assuming that we are even taking some assumptions here. We're assuming that samples that exceed the hypothetical ML are all excluded from the market with 100% probability of enforcement, which is not the case, right? When you enforce an ML, do you have 100% enforcement? No, you will always have some samples skipping the control system. But here, when I'm having this discussion with you, we are assuming that 100% of data points or of samples traded above the ML are removed from the stream. That's an assumption. To assess the impact on international trade of the commodity, the combined global data set should be used. We had this discussion. And if necessary, data sets for each region. But do you remember the reason where normally we have to consider the global data set, data points coming from all countries. But I might consider particular data sets for few regions in case they have really different occurrence. If they have a critically, statistically different occurrence, perhaps I might consider that their situation individually. Otherwise, if I adopt an ML without considering their situation, they will have plenty of products rejected from the stream. But I need to prove that. I need to have a clear proof why I am considering the global data set and the regional data set. Okay, you will have this discussion with Dr. Karima in the breakout room. For contaminants known to have large annual variation in concentration, the rejection rate should be calculated for the data set of each year. نفس المبدأ. The geographical consideration and the time consideration, and I can have some tests depending on particular countries or particular years. So this will be defined by the electronic weighting. Now, obviously, you deduced that it's a very easy calculation, okay? So simply, you can look at it visually. If I have the distribution, you can look at it in your Excel distribution, or if you have any software you're using, a very simple thing. It's just the number of data points above a certain value. This number divided by the total number of your data set times 100. That's it. So if we have this distribution, which is a proper distribution for the case of contaminants, right? We had our discussion with Dr. Eli. So that's the histogram distribution of my data set, for example. I took it like hypothetically. And let's say we are studying a hypothetical ML of 1 milligram per kilogram. What will be the rejection rate? What do you think? Do this very simple calculation. How many number of data points are above 1? Okay, these are the ranges of the values here for this histogram. So I have 5. So the calculation will be 5 divided by the total number, if you sum all these numbers, times 100. That's it. Okay? Or you will do it using Excel or in a very simple way. So the calculations for rejection rates are nothing to consider, okay? The basic type of calculation. So that's it. Hypothetical MLs can be estimated using available data, occurrence data, to explore the impact of potential regulatory limit. And we spoke here on the economical part, the trade part. Calculating rejection rates provide insights into the practical consequences of setting specific MLs. We do not want to disturb our international trade stream in an unacceptable way. These tools support evidence-based decision-making by balancing food safety objectives with trade and feasibility. So we spoke here about trade and feasibility, and here I invite Dr. Karima to speak to us about the safety objectives when setting those MLs. Thank you, everyone.